Good? Cool. Right. Where are my captions? Okay, I can't see the captions. Cool. Well, thanks for being here. It's a real pleasure to be up here. I've been to droidCon London many a times, and yeah, it's really great to see so many faces, especially on a Friday morning. I remember what the Thursdays used to get like. So yeah, if we haven't met before, my name's Joe. I'm an Android engineer at a company called Buffer, where I work on their social media tools, analytics tools, and customer support tools. Outside of Buffer, I also work with a charity called Sea Shepherd, who are combating illegal fishing, so I spend a lot of my time doing that as well. And other than that, I also enjoy exploring new technologies and kind of getting outside of my comfort zone. And today I want to talk about some very important topics that I think, as creators, we have a big responsibility for. And we're going to look at this through a story of a little bit of a side project of mine that I spent some time building. But first, I want to take a step back from technology, and I want to, think about something that's not technical content related. I think unintentionally, it's easy for us to become isolated from the things that are happening around us. And life is busy, and it's easy for us to get caught up in our own things. We can often forget or not even think about the things we are doing and how they might look for someone else. For example, how you got to this conference. Maybe if you were blind, deaf, or disabled in some way, that may have looked different for you. How would you have safely found your way to the public transport station? Maybe you flew here. Would you have boarded your plane without any hurdles? Maybe you might have had difficulties crossing that road just a couple of blocks away that was rather busy. And even if you did, carry out that stuff on that journey, fine, what you did on that journey might have looked different. Maybe you were on your phone, maybe you were conversing with people, whatever it was. And whilst people do these things, I think it's easy for us to think what kind of hurdles that might be introduced for them. And disabilities aren't always visible at first glance. I think the statistic is something like over 50% of people in the UK see disabilities as a physical impairment. So people could have disabilities and people could be experiencing things that we aren't, and at first glance we may not know those kind of things that are causing them those difficulties. And we often have a thing in the UK, we have parking bays which are reserved for disabled people. And sometimes you hear people make comments like when they see people getting out of the car and they're like, oh, why are they using that bay? They're not disabled. And that's a perfect example of that kind of stereotype that we have there on physical impairment being related directly to a disability. And with that statistic in mind, it's an interesting fact to see that 15% of the world's population has some form of disability. And that's equal to about 1 billion people worldwide, which is a rather large number. Seeing as there are so many different kinds of disabilities, there's a lot of the things that can be involved. And because as the years go by, this number is bound to rise in a kind of linear fashion because, as a species, we're living longer, and a lot of disabilities are often age-related. So naturally, those disabilities are going to be on the rise as we go through life, unless there is some form of medical breakthrough that happens in science. And because disabilities can also be accident-linked. So, sometimes you hear stories of people who have gradually lost their sight, or they've woken up and they've become blind due to some form of disease. Or maybe it's something where, I've heard stories of people jumping into lakes with their friends and they've hit a rock and become disabled. And this morning I was actually watching a video on the Google developers' YouTube, and it was about how they made Google Maps accessible for wheelchairs, and the routes that were planned through Google Maps now show wheelchair-accessible routes. And the engineer who worked on that tool became disabled a couple of years ago, and I think he's in his 40s, and he was on his normal walk to work, and he was walking through Central Park, just like he does every single day and has done for the last however many years. And part of a tree fell off of a branch. It was quite a large branch, apparently, and it landed on his head, which caused brain damage, and he actually lost the ability to walk from that accident. And that was just from something that he had been involved in, every day of his life, and that random thing just happened. And that can change the course of people's lives dramatically. And with that said, within the UK, these statistics are quite hard to find, so we're jumping between the US and UK a bit, so I apologise if there's a bit of confusion there at any times. But 17% of people who have disabilities within the UK were actually only born with them. So the rest of that 83% have developed them sometime in their life. So that's, out of that 11 million people, 83% of those have developed those disabilities, just like that story we just heard, sometime in their life. And I'm not trying to scaremonger you into this accessibility thing, but I just want to share some real facts there. And when it comes to these disabilities, there's actually a lot of different ones that come to mind. And there can be a lot of crossover. So the hurdles that someone may experience from being blind can also be experienced by someone else who may have some form of physical impairment as well. So I want to start off by just running through a couple of different disabilities and how they can affect people and the kind of numbers around them. So to begin with, we can see physical conditions. So these are things such as people in wheelchairs, maybe people have limb injuries or have conditions such as cerebral palsy. And for these users, we can see a number of different physical disabilities. For example, we have 1.2 million people in the UK who are wheelchair users, and this is a number that actually really surprised me because, I spend a lot of my time walking around. I'm guilty of it on my phone, like changing songs, texting people, and I'm just in my own little bubble. Maybe I've got my blinders on, and part of the time, there's probably loads of people who have been around me, who have been in wheelchairs and been in certain situations that I just haven't noticed before. And restricted growth is another one which is quite common in the UK and also worldwide. We have proportionate short stature, which is where someone has a general lack of growth in their body, as well as a disproportionate version of that as well, which means people can have limbs which are incredibly short. And that is something that when I first read about that, was quite interesting because things like, eating, some of us are privileged enough to have three meals a day. And when we're eating, when I'm eating, I'm rarely thinking about what I'm doing with my arms. I'm just like stuffing my face, enjoying my food. And even something such as simple as, holding a fork and being able to eat that meal would drastically change if you had something such as restrictive growth or something that was happening with your limbs. Another interesting one as well, which is often overlooked when it comes to even things such as creating mobile apps and digital experiences, are cognitive conditions. So these are things such as learning disabilities, something that affects our ability to either function and also learn. So 1.5 million people in the UK have learning disabilities. So that can be something like dyslexia, for example, which is common. I know a lot of people who have dyslexia. And also ADHD. And ADHD is also something that can affect the ability to learn. And ADHD is something that, whilst there's a bit of a misconception that this only really happens, the symptoms in children, this is actually 60% of people who have ADHD as children carry those symptoms through to adulthood. So something that has to be taken into account into the products that we are building, even just for adults and not just children. And autism is one that I didn't really think about too much originally when it came to building things or designing things. And there's actually, I don't want to talk too much about it, but if you have time to check out that link, it's a really interesting, some really interesting studies that were carried out by someone who worked on some design at Google, and how their study group of people with autism were really affected by the design of products. And there was one person in that study group, and actually no, I think it was all the people in that study group who used Facebook. And again, this isn't slating the Facebook website. It's just this is probably the same with a lot of websites and lots of experiences. But these people were using ad blockers to remove the content on the left and right-hand side of the website because the website was just too distracting, and they couldn't use the website. They couldn't focus on the actual content of the website. So they were using an ad blocker to remove the content of that site so that they could actually use the website. And these users don't use the mobile app because they can't do that same thing on the mobile app. So they don't even use the mobile app and they just resort to web so that they can cater the content how they want to see it themselves. And that's something that I never even thought about. So yeah, if you get a chance to check out that link, it's definitely worth looking at. Hearing loss is another one. We can have, there's 466 million people worldwide who have some form of hearing loss. Hearing loss, whilst that's slightly fewer numbers than the previous one, it's not a completely simple disability to look at. We can break this down into a couple of different types of hearing loss. But out of this number, there are 34 million people who are children, and the rest of them fall into an adult category. And this is another number that's predicted to rise to about 900 million by the time we get to 2050, and that's disabling hearing loss, so that's hearing loss that actually stops you or creates some form of hurdle for you doing something. And this is for a number of reasons, such as people not wearing protective hearing on work sites, music venues, and so on. Like, I used to play in bands, and I used to go to a lot of gigs, and I've never worn hearing protection, and that was probably really bad, because it doesn't take long of listening to loud music for you to actually cause damage to your ears. And we have two types of hearing loss. The first one is sensorineural hearing loss, and this is where there's actually damage that happens to the nerves in your ears or the hairs in your ears, which is often caused by things like diseases, hereditary conditions, or loud noises, like prolonged moments of loud noise, which can cause permanent damage to your ear. No pill, medicine, or anything can fix that. The only thing you can have there is a hearing aid, which makes you able to hear things better. But then again, as you saw in the introduction here, you have to have things such as hearing loops for you to be able to hook into those moments. We also have conductive hearing loss. So conductive hearing loss is something that stems from something like fluid, a blockage, or some form of more temporary thing that's in your ear that's reducing your ability to hear. So this is curable, and it's often seen as a more temporary hearing loss moment. But this kind of, rather than you not being able to hear as much, conductive hearing loss is more like a cloudy sound. So if you stuck your fingers in your ear and you started talking, that kind of sound is what you would hear if you had conductive hearing loss. And I couldn't get it working, but closed captions is often a good thing to have turned on for things like talks and videos, and just so your users can hook into that. So on the subject of hearing loss, there's also people who are mute, so people who can't talk and also can't hear. And this is kind of interesting because sometimes people are born with this, so born without being able to hear and not being able to talk. And some people have also got it from when they've gone deaf in their lifetime, and they're just out of the practice of talking, and they just slowly lose that ability to speak because they're just not used to it. And that's a really weird concept that I came across. And finally, vision impairment. And this is a huge one, 1.3 billion people worldwide. This is a thing that affects a lot of people, a lot more than the hearing loss thing that we looked at previously. And out of this number, we have 36 million people who are blind, which you cannot see at all. We have 217 million of that number who have moderate to severe vision impairment. There's also mild vision impairment, which makes up about 200 million, and that's like where your eyesight is affected even with correction. So even if you wear glasses, mild vision impairment is classed as you still not being able to see even if you have that correction in place. And then out of that number, there's about 830 million who have visual impairment from eye conditions. So that's things that are often irreversible and cannot be fixed, such as cataracts and other things such as diabetic retinopathy, which is caused by diabetes, and glaucoma and retinitis pigmentosa. Some of these you might not know of, but some of these you probably know some people in your family or relatives who have glaucoma is quite a big one in older generations, and cataracts as well. So it's likely that you would have heard of a few of these. And as you can see, these are quite blocking things of vision. For example, the one that's related to diabetes, like that completely removes your vision, and the blurriness and the black spots causes huge blocks in the things that you can see. And when it comes to these conditions, we have a couple of types of technologies which are created and designed to help people and to assist them in the things that they're doing. To begin with, we have accessible technology. So these are pieces of a technology that are designed specifically to solve the needs of an accessible requirement. So, for example, the Xbox One controller, some of you might have seen this before, some of you might not have heard of it, but this one is an accessible controller that allows people with specific disabilities to play games and interact with their friends via this medium. The inside of this controller is pretty much the same, apart from these two large pads, which just mimic the joypads which you have on the normal games controller. And this is such a powerful tool to empower everyone to be involved in gaming, which is a huge, huge thing in today's day and age. There's a video that Microsoft have on their YouTube of this, which will probably make your eyes water because it's just so great seeing how happy this tool makes these people. We also have a couple of spoons, which seem like such a primitive thing, but they actually become a huge part of people's day-to-day life. And these are made by a company called Liftware. On the left-hand side, we have the Liftware level. So this is designed for people with limited hand and arm ability. So essentially, wherever you move the handle, that spoon head stays level. So, you know, like a chicken. I don't know if you've ever picked up a chicken. It's kind of weird. But if you move a chicken around, its head stays in the same place. And this is where the idea for that came from. So if people have limited ability, they don't have to worry about their spoon tipping and things falling off of that spoon. And we also have the Liftware Steady on the right-hand side, which is designed and made for people with tremors. So if their hand's shaking, their food's going to fall off their spoon, they're not going to be able to eat it. What this does is it calculates the offset for the shake, and the spoon levels so that it just stays still. And that's seems like such a simple idea, but it's hugely popular amongst people with things like Parkinson's and so on. And I actually built a piece of accessible technology myself a couple of years ago that I called the Braille Box because I couldn't think of a better name. And it was essentially a portable Braille device that fetched a news article from an API and read it out in Braille for users so they could hit that button and keep in touch. And that was kind of for people who can't hear or can't, maybe they can't turn their TV on, maybe they can't hear the TV or see the TV. This device allowed them to hook into, the world and be able to keep in touch with what was going on. And as well as accessible technology, we also have assistive technology. So assistive technology are products that are just created for people without any thought about accessibility, but they just happen to serve a purpose for people who need accessible design. So other than the products being well-designed and mobile apps and being functional, we also have a lot of hardware products which fall into this category. So the first one is the Roomba. So not only is this product popular in general, but it's actually hugely popular for people with disabilities. If you haven't heard of the Roomba, essentially it's just a robot that just hoovers your room. So you place it on the floor, you turn it on, and it will just move around and start hoovering stuff. They do a couple of models. They also do one that maps your room, so it will map out your room and move around. And whilst this seems for me, I would probably buy this because I'm lazy and I couldn't be bothered to hoover. And I imagine that's why maybe a lot of people would buy it. But for people who have, or maybe they're not so, them have mobile impairments or they can't see, this is a huge tool because, it removes all of the hurdles involved with doing what seems like a simple task for us for hoovering. We also have other products of things that are unintended to be assistive. So these are things that set up themselves. So this is the only GIF I could find of something setting up itself, but a self-setting up tent. We also have similar things such as gazebos, barbecues, and furniture that do exactly the same thing, that just pop up and they set up themselves and removes all hurdles required to do something. I've never set up a tent, but whenever I've seen people do it, they look incredibly hard. And if I had, certain things that would create hurdles for me doing that, I can imagine it might be even harder at a first experience. So these kind of products create an accessible way for everyone to use them. And finally, we have voice assistants. So voice assistants make things so much easier for all of us, kind of like the Roomba and the self-setting up tents. Whether it's account management, music, or home automation, we are beginning to be able to control quite a lot by just using our voice or even, entering text to the Google Assistant. A usual task that may take numerous amount of clicks we can do in a couple of moments. And also for things like even changing the temperature in our home. Maybe I have to get out of my sofa, maybe I have to go to another room and change the thermostat. For me, whilst that involves a lot of effort of me getting out the chair, for someone who maybe isn't so mobile, that could be a huge difficult moment for them to do so, or even if someone who was blind, getting to that thermostat and having those difficulties. But being able to talk to a voice assistant and have those things do it for you just removes all of those hurdles completely, provided that the person has the ability to speak. And the assistant isn't marketed, or it wasn't even created with the sole purpose of being accessible, but it just happens to be a really accessible tool for a lot of people. And a year and a half ago, I built my first app for the Google Assistant, a simple tool that teaches you how to play the guitar. It used to just teach you how to play guitar chords. Do we have any guitar players in here? Oh, a couple. Nice. Cool. So a few people. Nice, cool. So I originally created this, as to be honest, there wasn't really anything that existed like that, and I wanted to build something for the Google Assistant, so I thought, oh, this would be a cool idea. You essentially ask the assistant how to play a chord. It will come back with you with an image, and it will talk to you how to play a chord. Nothing special going on there. And after creating the client, I started to have thoughts about how I could take this further. I've always been interested in the Internet of Things and hardware, so I started thinking about some crossover and physical products. What if I could stick this inside of a guitar, and the guitar itself became a conversational guitar tutor? Nothing like that existed, and the time I spent at school or with a tutor learning chords and songs, I could just do that from home. That's the dream, isn't it? So it sounded like a neat idea, and it also got me thinking about assistive tech. You know, whilst I would use this, and probably if it was a real product, like a lot of people who didn't need accessible tech would probably use this, it could be hugely useful for people with disabilities. Maybe going to a guitar tutor is hard, or maybe someone's unable to see or read the instructions from a computer screen or a laptop or a book. And this is where the spoken word from the guitar would have come in useful. So I want to jump back to the eye conditions a bit. So this is, and I want to focus down on the one on the bottom right, retinitis pigmentosa. It's a bit of a mouthful, so I'm just going to call it RP from now. So as we can see here, the progress of this condition can take away a lot of users' vision. And what we see on the right here is actually not as bad as a lot of people can get it. And this is actually a condition that runs on my mother's side of the family. And it essentially causes the cells in your eye to die off, which results in black spots in your vision. These spots can be random, like maybe you just have a couple of spots around your eye, or they can also group together to create larger blocks of visions, like so. And my grandmother also had the condition, and her vision was pretty much the size of a pinprick. Me or my siblings don't have it yet, so trying to find some wood to touch. But yeah, we've had tests, and it's looking all good so far. And I've always known about this condition, but I never really understood the severity of it. Maybe I was being a bit naive. But there are a few events that got me thinking more about it. I remember when I was about 21 or 22, my mum had a couple of cells show up during an eye test. These were dead cells. She already had some, but they were like in the corner, so she couldn't really see them. But she had one of these that was just in her central vision, and it was literally only just in the line. And this meant that she couldn't drive anymore. I always remember this because I remember being at uni, and me and my brother, one day we were too hungover to drive to university, so my mum drove us there. And that's the last memory I have of her driving. And it's weird, it seems like such a simple thing like that we're so used to, but for someone who maybe they live in the middle of nowhere, maybe they need to go to the doctors, or maybe they're supermarkets and they're so dependent on that thing, not being able to do that anymore can create such big hurdles. I mean, I think we're privileged enough to have my dad around to be able to take her to the doctors and hospitals, and sometimes she has to pay for the taxi or get public transport, but not everyone's in the same position, and those things can be reliable and costly. Another time was when I was in hospital with my grandmother, and we went to visit her, and I remember standing next to my mum, and we were talking to my nan, and I came up in the conversation, and my nan was like, "Oh, why didn't you bring Joe with you?" And it was like, it was a little bit awkward, because I was like, "Oh, I'm here, hi." And she laughed at it, and we laughed about it and stuff. But that was like, really got me thinking, like, wow, like, she was literally looking right at me, and she couldn't see me, and she didn't know I was there. Maybe I should have talked more, but yeah, she didn't know I was there. And for me, that was a bit of a like, oh wow, like made me realize how serious this condition can be. And this got me thinking more about it. And obviously, I had built the Braille box, but I wanted to do more. I was started to think about how, if I did have this condition, and I did have this condition when I was younger, how different might things have looked for me, like the things I do. I want you to take a moment to think about maybe things you enjoy doing outside of work. Let's forget about code for a moment. The things you enjoy doing. Maybe you like playing guitar, maybe you like football or drawing or so on. And for me, it's guitar. Like, I'm not a great guitarist, I'm going to be honest, but I love playing the guitar. It's always been a great way for me to switch off, have a creative outlet. And I played in bands when I was at college and university, so it was a huge confidence boost for me. And it was really, really appreciate that time. But if I had RP, I wondered how this might have looked for me learning guitar, whether it's getting to my guitar tutor, reading guitar tablature and books on the internet, listening or watching tutorial videos. And looking at other disabilities that we covered, like a lot of these would also have the same effect when talking about any of these things that we would be engaged with. And I'm not saying learning guitar wouldn't be possible if you had these disabilities, but I'm just thinking more how we can make these things more accessible and reduce those hurdles that do happen to help to suit the needs of these users. And with this in mind, I decided to take the Braille box, because it didn't really serve much purpose. It never got used. It actually sat in a cupboard for a couple of years. And then took that and the idea of the guitar I had with the Google Assistant, and I merged everything together into what I called Chord Assist. So Chord Assist is a guitar that is built to be accessible to a range of different needs. So it's only a prototype, and I probably feature creeps myself a bit. It probably has a lot more than it needs. But it has all the technologies put together to allow people who are blind, deaf, and even those without any disabilities to learn how to play the guitar. And in fact, most of its features are actually assistive technologies. So people without disabilities would probably happily use it without even realize that it's built to be accessible, even though I built it with accessible tech in mind. So the whole guitar is built around the concept of learning chords. And this is the foundational aspect of playing the guitar. Like, they could be introductory enough to ease you into the guitar, like, and get used to your fingers pressing down on those steel strings that actually really hurt, and as well as making up the parts of all the songs that you'll learn in future. And if you're not familiar with guitar chords, they're essentially a sequence of patterns which your fingers take place on the fretboard to make a collection of notes and play a nice sound. And when it comes to knowing how to play these chords, we'll either use this thing such as a visual representation of where to place our fingers, or we'll have just a set of instructions that reads out where our fingers need to go. So what the guitar does is it takes each one of these formats and gives it to the user in the way that they need it. So first of all, though, the user needs to be able to tell the guitar what chord they want to learn. So the guitar features a microphone, which allows for vocal input. So the user can say, tell me how to play the C chord to trigger the chord learning flow. And to cater for users who may not be able to speak, there is also controls on the screen that allows them to flick through the available chords and view the chords on the little screen which are retrieved from Firebase Firestore. And then they can hit the middle button, and that will trigger the chord learning flow in exactly the same way that asking the guitar would work. The guitar has 3 different outputs to cater for these different disabilities. It has a speaker, has a screen, and it also has a Braille reader. Each one of these can be enabled and disabled using these toggle switches, so the user can decide what one of the outputs or what collection of outputs they want to use. If the user has the speaker enabled, then the guitar will read out those instructions on how to play the chord, using the speaker which is fitted on the top end of the guitar. And if someone has the ability to hear, maybe they are blind and won't be able to use the visual output, then this allows them to learn the chord through an audio format. The screen on the top of the guitar is used to display the visual output, the chord diagram to the user. This is the old design I had for the chord diagrams, but we can clearly see how we can play the chord there. I think that was actually in debug mode because you can see the cursor on the screen, so oops. But for people who may be deaf, this allows them to learn the chords through that visual format. And finally, on the bottom side of the guitar is a Braille reader, which will read out the texture instructions for how to play that chord in a Braille format. And that's slowed down a bit just so you can see them moving, but we can see those pins popping up and down to read out those instructions. And this will be used by people who are blind and or deaf to read how to play that chord in a Braille format. So when it comes to what the guitar is made up of, there are a range of different technologies that have been used. So there's no Android here, I'm afraid. In fact, BrailleBox was originally built using Android things. So if you're still using Android things, you could perfectly build something like this. But when I came to building the client for the guitar, the announcement for the, I think it was the deprecation of Android things happened. And so I decided to flip and just use a native Raspberry Pi instead. And the guitar ended up taking a bunch of these different technologies to make it all possible. So I'm going to be honest, at the time, I had no clue how half of them worked. I've used Firebase a bit before in Android projects, and I'd already built the conversational tool, but I had no experience with the other things. I'd never written any Python. I had Raspberry Pi for about 4 years sitting in my cupboard, because I remember when they got released, and I thought, oh, this is cool, I'm going to build something, and I could never think of anything to build. So I'd never built anything on the Raspberry Pi. Communicating with Google Cloud services, other than SDKs, I'd never done. So there was a lot of unknowns and a lot that I didn't know how to use. And a lot of this project was actually trial and error. There was a lot of stresses and a lot of times where I didn't know what the hell I was doing, but it made it a lot of fun, and there was a huge amount of learning involved in that process. So we start with the Raspberry Pi, and this is the core part of the project. So everything that is in the guitar routes through this little thing. You may be familiar with them, or maybe you already have one, but they only cost about £35, and they have a lot of range for what they can enable. So I want to dive now into all of the different things that this enables the guitar to do. So as previously mentioned, we have two core ways in which a user can interact with the guitar. They can either select a chord how to learn, or they can request to play a chord using their voice. So I want to begin by looking at the asking of learning how to play a chord. And this is the part that is driven by the conversational tool that's running on the Raspberry Pi inside of the guitar. So the conversational side of the guitar is powered by Actions on Google. This is essentially the brain of the guitar as it brings everything together and it drives that whole learning process. If you're not familiar with Actions on Google, I hate to say this and I apologize in advance now if I trigger all of your devices, but if I say, OK, Google, the actions you trigger with that are powered by Actions on Google. So the tool offers an SDK along with some services that kind of abstract the complexities of building actions for the tool. And one of these is known as Dialogflow. And this is the service that I originally used to create that conversational tool before. And there are several concepts that come into play when building a conversational tool in Dialogflow. The first and probably most important part is an entity. So this is like a data class that we'd have in Kotlin. It represents an object which can be linked to a task that an action can execute. So because in the case of the chord assist, the user is asking how to learn a chord, our entity here is a chord. And this entity has all the possible values that that entity can be. So kind of like maybe we were defining an enum or something, we'd have all these different chords that can be possible, along with all the different phrases that can link to an entity. So in the case of a G chord down the bottom here, the user could say, teach me the G, teach me the G chord, or tell me how to play the chord G. And the Dialogflow would know that the user wants to learn that G chord. So an entity could be anything, like a user, a tweet, I don't know, a profile picture. It just represents some form of object. And for our action, for the chord assist action, we also have intents. These intents are tasks that the user can trigger. So in the grander scheme of things, maybe it's book a taxi, order some food, view my account balance. In the sense of chord assist, we have learn chord. There are a bunch of other things that it does here, but we just want to focus on this learn chord intent. For each intent, we also define, wrong one. So for each intent, we have a list of phrases which can be used to trigger that intent. So here we have all the different things that you could say that would trigger the learn chord intent. So tell me a chord, show me a chord, I want to learn how to play a chord, and so on. For each intent, we also declare if there are any required entities. So because we are learning how to play a chord, this intent requires a chord to be able to complete the fulfillment. So when we speak to one of the phrases, tell me how to play a chord, we haven't given it a chord there. So Dialogflow will be like, I need this chord, and it will prompt the user to give it a chord value, which is when the user would say the G chord or the D chord. But it's also quite clever. So we can also use phrases that already include the chord. So if I said, tell me how to play the C chord, which already maps to that learn chord intent, which depends on a chord entity, Dialogflow is intelligent enough to pick out that chord and use that in the fulfillment request, which is pretty clever. So using Dialogflow, like whilst building a conversational guitar sounds kind of a big job at first, this is a lot of the work and it takes out all of those complexities for us. So we have this flow from the guitar where we request a chord. The requested chord will be the process through the spoken phase, and then we have the Dialogflow app. For the learn chord intent, we need to calculate all the different chord patterns and the images, which we can't do inside of Dialogflow, even though that's not complex work. So for this, we essentially provide a webhook URL to Dialogflow, which will make a request to our external app and get the data back from that. So for this external app that's hosted on the Google App Cloud, we have essentially a little app that's just running some scripts that basically, when the webhook is used, it will link to this and return a response. So for this, we have a Kotlin client library for Actions on Google. So if you're familiar with writing Kotlin, you'll probably be comfortable writing this code. So in this side of this code, we essentially write functions that link directly to the intent that has been triggered. So we had that learn chord intent, and here all I have is an annotated function that's linked to my learn chord intent. So whenever the webhook is used, the intent will be mapped to here, and this function will be called. Now, this function isn't doing anything magical. All it's doing is it gets the chord that the user wants to learn, and it puts together the string for E string open, B string fret 1, and so on. It puts together all that text and returns it to the conversational tool. So here we're just using the SDK's response builder to build that response and so on. I've omitted the parts of building the chord strings because it's not too complex and it's not very interesting to look at. But once that's all done, we just return the response builder, and that returns everything to Dialogflow. I don't want to go too much into this, but I actually spoke about building that little app here last year. So the video is on the Skills Matter website. So if you want to learn more about the actual building of the conversational app, then I'll run through it all in that video completely. But how does this link to the guitar? So we've got this conversational app that works on the Google Assistant. It works on my phone. But we want to run it on the guitar now. So we need to hook in that conversational flow. So we have the microphone for voice input, but we need to actually capture the user's speech and then communicate with the Dialogflow server. So the microphone here, this little bit in the middle, is just a USB microphone that connects directly to the Raspberry Pi. There's nothing fancy there. There's no electronics. It's just plug and play. And in terms of the code, the Google Cloud Speech-to-Text SDK is used to capture the spoken audio from the user and then convert it to text. And once we have that, we send it off to this detect intent text function, which will fire off the request to Dialogflow using the given text. And as you can see here, the guitar doesn't actually require much work from our side to communicate with Dialogflow. The Cloud Speech Client, the Google Cloud SDK, handles this speech recognition for us, and it just gives us back the text that's spoken. So in a couple of lines of code, we have that conversational request from the user, which we can then use the text to send to Dialogflow. As well as this voice communication, we also need to handle the user selecting a chord that they want to learn. So for this, we needed several components. We have a 4-character segment display, as well as a couple of buttons which are used for the navigation. For this segment display, I was originally going to use individual segment displays and communicate with them manually, but I found this plug-and-play text component from a company called Pimoroni. Only costs £10. I actually bought 3 of them because I burnt the first 2 out when I was soldering, so probably a bit of a loss there. But this is essentially just a plug-and-play component which plugs directly into the Raspberry Pi, and it even comes with a Python library that you just send strings, and it does all the hard work for you. And in terms of code, for this navigational aspect, these chords actually come from Firebase, but I've omitted this for simplicity. All we do here is we keep track of the selected chord position when the user pushes the navigational things, and we just flick through the selected chord and update what's shown on the screen. So this display of the chord is just using this FLP library, so they call it, and we just print the string to that and show it. So that a lot of that hard work is done for us there, and we're just keeping track of the selected position in a simple integer format. And when the user hits submit, all we do is we get the selected chord, and then remember how in our tent we were saying, tell me how to play the C chord? All we do here is we take the chord that's currently selected and manually build this speech string and send it to exactly the same function. So both things hook into exactly the same flow. In terms of wiring, I'm not an electronics person, so if anyone wants me to point this out to me that this is wrong, let me know. But in terms of wiring for those buttons, there wasn't actually much that was involved. We communicate with the Raspberry Pi using GPIO, which is known as General Purpose Input-Output. And this essentially is a protocol used to both retrieve and send data in the form of high and low bits. So each button is just wired to a positive power value along with a negative point. And when each button is pressed, a high value is sent to the GPIO pin for the button that it's connected to. And then in the code, we just know that we have that listener for when that button is pressed. So when it comes to those, we've got our users selected a chord, users spoken to the guitar, and we need to make the request to Dialogflow. When this happens, we need to let the user know that something is going on. So if it's the screen, we show a spinner. If it's a speaker, we just make a loading sound. But the user might have the brow enabled. And for this, we just have a simple little vibrating motor. So if the user is blind and deaf and they need to know that something is happening, they can place their finger on this small motor and it will vibrate like a progress indicator just to let them know that something is going on. And this idea was actually taken from something we have in the UK on the bottom of traffic lights. I don't know if you've seen these before, but next time you're at traffic lights, if you put your hand underneath the box, there's this little thing that spins round. And I think they have them on all of them, maybe not the older ones, but essentially when it's safe to cross, I think it is, these spin round. So people who are blind, and some traffic lights don't have the sounds, they can hold that and they can wait until that starts spinning, and then they can safely cross. And that idea was taken from that. So we're taking like real-world concepts and real-world assistive bits of technology and placing them inside our own projects. So at this point, we've handled the user input and sent this off to Dialogflow for processing. But now we need to actually handle that response that we get back from Dialogflow. When we get the response back, there is a lot that can happen because we have these 3 different types of output. We have the screen, we have the speaker, and we have the braille output as well. So because of this, we provided toggles for the guitar so that these different outputs can be enabled and disabled as per the requirements of the user. And these toggles are just represented by Boolean flags inside of our code. So we flip each flag based on the toggle state, and then when it comes to handling the response from Dialogflow, we use these flags to determine what one should be used. So again, nothing fancy going on there. We're just using Boolean flags. There's probably a better way I could do that, but it was kind of just something hacked together, and we're just keeping track of what features are enabled and disabled. And again, these are just similar to the way we wired the buttons together. They're communicated via GPIO. So before we dive into each output, let's take a quick look at this detect intent text function that we've seen being called a couple of times in the code. And this is the function that talks to Dialogflow using the SDK. And again, there's not too much to put this together. So we begin by importing a reference to the Dialogflow SDK and creating an instance of the client that will be used to make our requests. We then create a new session for our conversation using both our project ID and a session ID. So the session ID is essentially just used so that when the user is conversing, Dialogflow knows that that is part of the same conversation. Next, we create our input for the query, and then we use our session client to trigger the detect intent flow. So this sends our data to Dialogflow, handles the request and any fulfillment that is involved, everything happens in the cloud, and then that will return that to the guitar, and we can handle that response in the way that we want. As you can see below, we fetch each of the required data from the response using just the JSON response that we get back. In terms of handling this response, let's begin by taking a look at the screen which is used to display the chord to the user. So there's a couple of steps here, and we first need to download the chord from Firebase using the response and then display it on the screen. So when it comes to this, again, the code doesn't actually consist of too much thanks to the SDKs that we've used. We start here by creating a new reference to the Google Cloud Storage client, assigning a bucket, which is essentially a storage location which you get from your dashboard, and this is where our images are stored. We next retrieve the blob for the file, download the file, and then save the reference inside of a local variable so that we can display it on the screen. So at this point, we have our downloaded image, and it's handled asynchronously for us inside of the code by the SDK. Once done, we pass this reference back to our callback, and the chord is displayed on the screen within our UI. So I'm using a UI framework called, I think it's called PyQt, and it's quite a known and established client framework, and there's a lot of tutorials online, but I've kind of omitted the code here. But all that does is just creates a window and shows that chord, loads that image into the window. Next, we have the speaker, and this is where we're going to play the audio for the text response from our chord instructions. Luckily for us, the Raspberry Pi has some built-in functionality that handles text-to-speech, so we don't have to do any extra work here. What we do is we take our text that we've got back from the Dialogflow response, and then we pass it to this command line text, which allows us to define the pitch, the speech, and so on. And we run this command line script, this pico to wave, and this converts our text to an audio format. So this doesn't give us the same voice as the Google Assistant, but it gives us it's not too robotic. it's tolerable, and yeah, so that's a built-in functionality in a few lines of code that allows us to speak those instructions to the user. And again, that speaker is just connected to the jack of the Raspberry Pi. So our last step in this process, which is probably my favorite, is the reading of the chord instructions in the Braille format. So the pins themselves are pretty cool. They're components called solenoids, and they're originally intended for things such as turning water pumps on and off, and they have a little cylinder which moves up and down and when they receive power. So they're not intended for this kind of thing at all. But I think this is a cool example of how you can find electronic components that are cheap and make them work to the way that you want them to. I took these, I cut a wooden craft ball in half and stuck it on top to create a smooth surface for the fingers. And the problem I faced here was that the Raspberry Pi does not provide enough power to actually make these pop up and down. So the Raspberry Pi, the GPIO pins only provide 3.3 volts of power, and these solenoids require 5 volts of power. So whilst you could use it, you would actually cause damage to the Raspberry Pi and eventually fry things. And during the build of BrailleBox, I did actually burn out quite a few solenoids and break my old Raspberry Pi because of this, because there's just too much power being drawn from the Pi. For this reason, I got hold of a relay switch. Didn't know if it was going to solve my problems, but I Googled a bit, and apparently this is what people use for it. So each one of these modules connects to a GPIO pin of the Raspberry Pi, and essentially these act as a switch. So when the GPIO pin communicates with one of these modules, it switches it on and off, which will then give the power to our solenoid. These relays contains components, maybe it's diodes, I'm not sure, which essentially amplify the current that have been sent to them. So when the Raspberry Pi sends to 3.3 volts, this will amplify it to 5 volts, which makes it safe for us to use. When it comes to the code for the Braille, it's probably a little more involved than the rest of the project, just because there's a lot of manual hard coding. So basically, we need to map each word and each of its characters to a Braille format. And this gives us a collection of Braille representations. So for this, I essentially have an enum that represents each available value in the alphabet, numerical string, and some special characters also. So you can only imagine how long that took to type out. And what we see here in the form of ones and zeros are the binary representations for the Braille that we want to display. And this essentially tells each of the solenoid pins what ones need to be up and down. So we have the ones and zeros, and then, so this will be, one pin needs to be powered, and the rest of them need to be unpowered. So as we flick through these sequences, the pins will move up and down accordingly to represent each of those patterns. And when it comes to covering this, we essentially have a function that takes the text that needs to be converted, it loops through each of the characters in that text, and then builds a string that is made up of each of those Braille representations. And finally, we take each of those Braille representations that we got from our previous function and display them on the reader. We give a small pause between each one just to not to go too quick, and we can see in the display sequence function that we set each of these pins to high or low, dependent on whether the Braille at the index is at a high value or not. And what would be nice would be to have like a speed switch on the guitar so that the user could control the speed of the Braille, and this would essentially be based off of that variable. And that's the whole project in terms of the electronics and code. This looks a bit messy. I lost the file for this image, so I couldn't actually tidy it up for the talk. But I just wanted to show that there wasn't actually much soldering involved, and a lot of it was plug and play. Because the soldering and stuff in electronics is what originally put me off of these kind of projects, because, to be honest, like I said, I don't have too much experience there, and it can be a bit overwhelming. But in terms of the soldering and wiring, there wasn't too much that was going on that needed to piece all of this together. So I started off to look a bit more about the actual make process itself, which was a little bit daunting. I started off with a clean guitar from a charity shop. It's actually worth about £300, but I got it for 80. So I'm not sure if the people knew, but it was for a good reason. So yeah, got it for about £80. And it was a nice clean guitar, played well, sounded nice, and I took a Dremel to it. Which is probably the hardest thing I've ever done. Like, imagine taking something that you love and you really enjoy doing and just drilling a hole in it, not sure if it's going to work or fit properly. Like, I tried to measure things as best as I could. So yeah, that was pretty fun. And we drilled some holes and slowly started validating that the component fits. So these holes were literally just drilled. And obviously the drills are quite small, so I just moved the drill in a circular motion until the hole was big enough and just kept checking if stuff fits. If you take those buttons out, the holes are horrific and they look really bad, but you can't see that once the buttons are in there. And And the more holes I cut and put things inside, the more I started seeing it come together. And at this point, I remember being really excited to see the buttons in there, and it was cool to see the speaker in there and see stuff in there. But at that point, I remembered I hadn't actually put anything together or checked that it worked. So it was cool to see it coming together, but yeah, I still had the big task of putting it all in there. And when it came to the electronics, I originally had everything in breadboards, which are like plug-and-play boards. We could just take stuff out. But when I put all these inside of the guitar, everything kept coming in unplugged. So I had to switch to soldering boards to keep everything in place and stop them from moving. And then also put everything inside of these project boxes to stop things becoming short-circuited and stop all the electronics touching each other and so on. And this is probably less than half of what ended up in the guitar itself. There were 5 project boxes in total, along with the Pi, the relay board, and also I brought this portable phone battery, like a large one, it's about that big, that just sits at the bottom of the guitar that's glued down there, so that it powers the Pi. Hasn't run out yet, so that's going to be fun to charge when I need to charge it. So everything is kind of, as I said, placed inside the guitar. Apologize for the photo. It was really hard to get a picture inside the guitar that was like everything in focus. But I basically just propped everything along the sides. Like, it doesn't look too bad from the outside, but the inside's pretty messy. And things are just glued in place and propped up with bits of wood to hold them securely. And nothing's fallen out yet. So basically what I did was I brought something called an F-clamp. And this F-clamp, glued things in place with blocks, used an F-clamp, and hold things in place whilst it all dried. And I had to do this for each of the braille pins as well, because they obviously needed to stay in a specific place to allow the pins to move up and down. So this clamp helped to make that dry. And once everything was in there and put together, we have a perfectly working guitar, and you can see the wires are in there and stuff. And it's funny because I thought it would affect the sound, but it didn't. Maybe to a professional musician, you might notice some difference, but compared to my other guitars and how it sounded before, it doesn't actually affect the sound too much, even though there's a lot going on in there. And all of this process was completely different from my day-to-day work. I'm so confined to creating experiences for the small screen at work, but this project and its process was a whole different world. And being outside of my little green Android bubble helped to open my eyes to some of the core issues around me. And these are definitely things that now have got me thinking more about accessibility and how people experience certain things that I will definitely be taking and have started taking back to my day-to-day work to try and make the things that I build on mobile even better. And if it wasn't for the Google Assistant, I'm not sure how this would have turned out. I probably could have tried to create a natural language processing tool, but I struggled enough with the electronics, so I'm not sure how far I would have got with that. And the technology is something that is available to us all, not only to use, but to create for. Whether we embed it in an IoT device, whether we have it as an extension to our app, whether it's accessible from our mobile phones through the Assistant. But there are a lot of apps that don't utilize the Assistant yet. For example, none of my banking apps do that. Sorry, I know a few of my friends are here from banking apps, but having an Assistant app for my bank would save me a lot of time of having to go into my app, log in, check my balance, or freeze my account, or move money somewhere. And that's just one example. And there's so many apps that I have that don't utilize these functionalities that could really help make those things more accessible. So think what they could do for people who do face those hurdles. And during my research on disabilities, I came across this phrase, learned helplessness. And it was used by someone, it was about 15 years ago, I think the quote was from, so things obviously might be a bit better since then. But it was someone who had developed a disability at some point in their life. So they were used to being able to do everything without facing any hurdles. And they felt like they had learned to become helpless. Because of the lack of tools and the lack of accessibility for the things that they used and interacted with, they kind of just accepted that that was how it was, and they had learned to become helpless with the things that they were once used to doing. And I think as creators, designers, engineers, or whatever we call ourselves, I believe it's our responsibility to discover and build these solutions into the things that we make to prevent these kind of feelings and to prevent people feeling like this, and to bring a sense of levelness across abilities for the products that we build. And so to end the talk, if I could ask one thing of you all, if you're not already, maybe start thinking about the things you do and engage in, regardless of how small and insignificant they are. Maybe it's eating your lunch, maybe it's standing there chatting with your friends, going to work, making a coffee. Start thinking about how they might look for other people and how you would carry out those things if things were different for you. And maybe then we can start thinking about solutions and building things for everyone. That's all. And we've got a couple of minutes. If there is any Q&A or if people want to come and chat afterwards, that's great. I've got some Google Assistant swag if anyone wants any pins and stuff. So feel free to come and chat to me afterwards if you don't want to ask questions now. But I think we've got a few minutes if you want to ask anything.
Hello. Why did you do a separate device from the guitar? Why did you have to put everything in the guitar? Just a random question.
Yeah, so that's one of the things that I've actually been asked a few times, basically because it would have probably been harder to put it on outside of the guitar. Like one of the ideas that I've been having is building a detachable component, like that slots on the back of the guitar and has a screen and stuff built on, but that's introduces a lot more complexities just because it's, it could be bulkier and it's a bit more difficult to get so compact. So to be honest, it was just because it was easier and allowed me to contain a lot of the mess inside of the guitar.
Thank you.
Any other questions?
Cool. Well, if not, I'll be around for a bit. And so if you want to come chat, whether it's about Android, whether it's about this or whatever, feel free to come talk. And thanks for coming.